All right, boys and girls. Today during science class, we are going to be completing a simulation experiment that entails measuring the state of matter in given atoms and molecules. But before we begin, I am going to refresh your memory on the material that we learned in class last week. We learned that there are three states of matter. There are solids, liquids, and gases. We learned that solids are molecules held together by strong bonds, and that they can keep their own shape and size. We learned that liquids are molecules that have weaker bonds and that they can't keep their shape unless they're in a container. And lastly, we learned that gases are molecules that are free to move around and that they can't keep their shape unless they're in a sealed container. Now it is time to begin our simulation experiment. Throughout this simulation, we will be periodically changing the temperature and pressure of neon, argon, oxygen, and water to measure the adverse effects that this places on the state of matter. We will also be using a phase diagram to check and see if our findings are accurate. We're going to start out by adding some pressure to our neon molecules. And they're currently at a solid state of matter right now. And when pressure is added, you can see that these strong bonds break apart and form to a liquid and then a gas. Now, if we add some cooling to our gas molecules, let's see what happens. You should see that on the phase diagram, it is changing from a gas to a liquid. These molecules are coming closer together and forming bonds. They're at a liquid state of matter, the critical point, and then they form to a solid state of matter. And if we were to add heat, it would do the complete opposite, and these bonds would break apart. Now, if we were to add some pressure to our argon molecules, let's see what would happen. And they're currently at a liquid state of matter. Once again, these molecules are spreading apart, moving faster. And if I were to add some cooling, so these molecules are at a gas state of matter, and if I added some cooling to these argon molecules, they would transform from a gas state of matter to the liquid state of matter. You can see that these bonds are forming closer together. You can actually pause this and see that they're at a liquid state of matter. You can go in slow-mo to see that they're getting closer together, but they're not exactly at a solid just yet. If I continue to cool this, it's going to transform to a solid state of matter. Then for oxygen, so oxygen molecules are currently at a solid state of matter. When I add pressure, once again, these molecules break apart and they form to a liquid and then a gas. And then when I add some cooling to these oxygen molecules, they transform from a gas to a liquid to a solid. You can see the temperature is currently dropping, and it takes a little while, but there we go. These molecules, you can see they're forming closer together. These bonds are becoming stronger. We're at the critical point, and now the triple point. And once again, if we added heat to these molecules, they would do the complete opposite, and they would spread apart. And then let's add some pressure to our water molecules. They're currently at a solid state of matter. When pressure's added, the molecules break apart. Now they're at a gas. Now let's cool them. These molecules are currently spread far apart, and you can see now that they're forming closer together. They're at the critical point. Now they've reached the triple point. Once again, if heat was added, they would do the complete opposite. And that wraps up our lesson for today. Great job, boys and girls. We will now be taking an assessment.